Whew, that was actually a really, really, really long answer. That was question 4, and now we're at question 5 here. Question 5 is an organic chemistry kind of question. So it says here, draw the products of the reactions here. So let's see. Of any reactions that take place. So I have cyclohexane, cyclohexanol, cyclohexanone, and benzaldehyde here. And basically, I'm reacting it with Br2 with dichloro. This is dichloromethane here. So if I want to figure this out, I would have to simply just do this would be a bromination reaction of cyclohexane here, but however it's under CH2Cl2, right? So this here dichloromethane, it's not going to, I have bromine under dichloromethane. This solvent is it's simply just a polar solvent for my bromine, right? In this case, it's actually not going to react because I have an alkane group. Again, if I want to chlorinate it, I need to use radical halogenation for me to get some type of reaction here. So in this case, hexane has no reaction with this one. It does not go through an oxidation reaction or a reduction reaction here. KMNO4 is an oxidation, is an oxidative oxidizing reagent, so it's not going to be reduced. CrO3 is chromium trioxide. This is a reduction. Oh no, this is also an oxidation. Sorry, also an oxidation oxidation reagent here, and then D2,4-DNP would be our. Let me just see which this says. This is a Brady's reagent, I believe. And this would be to solve for your to get a nitro group into your it's basically just detects carbonyl functionality of a ketone or aldehyde group, and I believe it turns some specific color when you put it into that solution. I believe it's red or yellow. I think it's yellow. Let me just verify that. Just give me a second. A positive test is signaled. Yeah, yellow, orange, or red precipitate. So you get dinitrophenyl hydrazone if you get a ketone or aldehyde group here. So in this case here, cyclohexane does not mean anything. That's fine. But cyclohexene, it does. I do have a reaction, right? Cyclohexene with Br2 would give me simply just I'm adding towards the double bond, right? So this here with Br2 and CH2Cl2, I would get basically a bromination reaction. I get Br and Br here. So that would be, I would fill this out here. Again, CrO3, again, chromium trioxide, and KMNO4 would just be basically oxidation reactions here. And again, I don't have a alcohol group here. D4NP, again, I don't have a carbonyl group here, so I won't get a reaction here. So that's cyclohexene. Let's look at cyclohexanol. Cyclohexanol would be OH. If I react it with Br2, I will get no reaction. Again, the OH group is a tough leaving group. This is a very, very strong bond, and it will not leave. Br2 would not substitute OH, so would not get a reaction here. CrO3 over in the presence of acetone as its solvent would give me a oxidation reaction. It would give me an oxidation, and I would get a ketone, right? Same with if I were to use KMNO4, I would also get a ketone here. In this case, I wouldn't get a carboxylic acid because again, this alcohol here is a secondary alcohol. I cannot reduce secondary alcohols to carboxylic acid. So in this case, these two products would give me that. Again, with D4NP, DNP, again, I don't have a carbonyl group, which means I won't get some sort of product here, which is fine. And then finally, I have hexanone. Hexanone would not react with bromine. Again, I'm not substituting this O. Again, I can't oxidize this any further, so I don't get a reaction here. However, with D4-DNP, it will make a product, and again, it will make the red precipitate that we talked about here. So that's great. So D4-NP will make a reaction here. And finally, benzaldehyde. Again, Br2 will not substitute it. That's fine. CrO3, let me just check the strength of CrO3 for you real quick. Chromium trioxide is it enough to oxidize to a carboxylic acid? I know KMnO4 would be, because potassium permanganate is a very strong oxidizing reagent. Let me just check if it's a strong or again, it is a strong oxidizing reagent. So in this case, benzaldehyde would reduce to a oxidize to a carboxylic acid. So you get something like this. So you would get OH, and this would basically oxidize. So I'm going to do an O here. This would be a benzene again, and then we get a carboxylic acid, like so. And then in the presence of D4-DNP, again, because I do have a carbonyl group, I will make my red and orange precipitate. So let me look at the answer here. And again, this is correct, right? Again, I don't get a reaction here. I even took it a step further, and I actually like wrote out the products. Again, no reactions for alkanes like stated before. Br2 again will definitely add to the double bond, like Br here and Br here. KMnO4 would react with cyclohexene to oxidize. Let me just double check that. I believe that's true. Oxidizing alkenes. And I believe that it can basically cleave the bond, right? Let me just, you would get basically, oh, you wouldn't cleave the bond, but you would get, it would add a diol group. So let me just write this down for you. You have an alkene here, and if you react it with KMnO4, like a very, very strong oxidizing reagent, in this case, CrO3 would not do the same thing. This it's just a because KMnO4 again, it's basically the strongest oxidizing reagent. It's going to form a diol here. So I have OH here and OH here. So it will react with the KMnO4, but not with CrO3. Cyclohexanol, again, I can oxidize both of these to make a ketone, so both these are correct. Hexanone, again, I would only get D4-DNP. There should be a check mark here. Again, I do get a colorless, it basically detects a carbonyl group, and this here, a ketone is my carbonyl group, so that's good. And finally, benzaldehyde, I can oxidize both of these to become carboxylic acids, and it will become a red precipitate in D4-DNP. So this solution here is correct. This solution is correct. Again, CrO3 here only reacts with aldehydes and alcohols and not alkenes. It's just because KMnO4 is such a big, such a strong oxidizing reactions that they can actually produce a diol here. Solution is correct.